Welcome back. This is an Aleks training video on identifying phase transitions on a heating curve. The heating curve is very useful to tell you when something has gone from a solid to a liquid and from a liquid to a gas. There's a certain amount of energy it takes to raise the temperature of something, and there's a certain amount of energy it takes just to melt something. So you can have very, very cold ice, let's say 500 below zero ice. And if you add energy to it in the form of heat, the temperature of that ice will go up from 500 below zero to 400 below zero, and then eventually to 100 below zero. And you add more energy, and eventually it gets up to zero, but it's still ice. So at 0 degrees Celsius, ice is still there as ice. But if you add more heat to it, the temperature stays at 0 and the heat is turned into melting the ice. That's called the heat of fusion. Okay, so let me show you a schematic. Okay, in red, if you go up to from A to B, you increase the energy. Now look along the bottom. The bottom is heat added. So you keep adding heat, keep adding heat. So if you go from A to B, you've moved to the right. You've added heat, and you brought the ice up from a low below 0 degrees up to 0. So at B, it's still 0 degrees. And if you add more heat, at C, it's still 0 degrees. That heat does not go to adding temperature to that. All it's doing is turning the solid ice into liquid water. Okay, that's called the heat of fusion. From C, if you increase the amount of energy in the form of temperature, you add more and more temperature to that water, and now you've got 1 degree water and 10 degree water and 30 degree water. Eventually you get up to D, which is 100 degree water, and that water is 100 degrees. The more energy that you add after that doesn't raise it up. It's going to instead turn that liquid water into steam. So that's called the heat of vaporization. So these two red lines, first one is heat of fusion, that's melting. Okay, and you put heat into it, it'll melt. If you took heat away from it, it would freeze. So it's the freezing point and the melting point. At D to E, that's the heat of vaporization. If you add heat at D, it'll turn it into steam. If you suck away heat at E, it'll turn it into water and it'll condense the water. Okay, so that's what you're seeing in this blue line. So all of the information is here. They're just asking you to read it. Okay, so let's look over to the left, and you're asked what the boiling point of X is. Okay, substance X. Well, boiling point. Boiling is when it turns from a liquid to a gas. Okay, so let's go through. It's going to start here at a solid. It's going to go up here to this point, and then this is about 95, and it'll start melting. This is the energy it takes to melt it. So at 95, it stays 95 here, and now it's liquid. If you add any energy from here, it's going to turn this into, this is still a liquid at 130, and then you add more energy, it stays 130, but now it's no longer liquid, it's gas, and if you increase the energy to it, the gas can get hotter and hotter and hotter. So you can have 1,000 degree gas or 10,000 degree gas. Okay, so this is saying, what is the boiling point of X? Well, you go from here, and that is 130 degrees Celsius. Okay, 130 degrees Celsius. The second question is, what phase, physical state of X, would you expect to find the flask after 5 kilojoules of heat has been added? Okay, so we're going to go along the bottom from 0 to 5. Okay, from 0 to 5, what's going on? Well, it's already started. This is all going to be solid. This is all going to be liquid. So halfway between, you're going to have some solid still, because not all of it has melted. It's not going to all melt till it gets to here, but some of it started to melt. So you're going to have kind of a halfway point, and so you're going to have some solid and some liquid at 5 degrees of kilojoules per mole of heat. Okay? Hope you learned something today.